Hi, if you've been having difficulty with the Chapter 6 homework, questions 16, 18 and 20, then this video is for you. Now, I'm not going to run through the actual problems because if you don't solve them for yourself, you're not going to learn anything. So what I am going to do is run through some very similar problems to the ones that you've been assigned. Here's the first problem, similar to 16.6. Given a sample of gas that expands from 14.3 mil to 21.5 mil, you're asked what is the work done if the gas expands first of all against a vacuum, secondly against a constant pressure of 1.50 atm, and finally against a constant pressure of 3.7 atm. For part A, let's just think about what the question is asking. We're asking about an expansion against a vacuum. Now, if we're working against a vacuum, then our system is expanding against the surroundings, but the surroundings have no pressure, so there's no resistance to that expansion. So the external pressure is zero, no work is done during the expansion. We can express the work done by the system using our equation work is equal to minus P delta V. The delta V represents the change in volume, the P is the pressure, and we use the negative sign because this is expansion work and the system is doing work on the surroundings. So next we calculate the work done by the system by substituting our data. We put in the negative sign and then the pressure, which is a vacuum, so the pressure is zero. Next we calculate the change in volume. Remember, when we calculate a change in volume, we start with the final volume and subtract from that the volume that we started with. That's 21.5 minus 11.3. Don't forget the units, mil. And so there's our solution to part A. In part B, we have an expansion, this time against an external pressure of 1.50 atm. To expand, our gas sample has to overcome that external pressure. So we'll use our formula, work is equal to minus P delta V for expansion work, and we'll substitute our data, which is minus 1.50 atm multiplied by the change in volume, which was 21.5 minus 11.3 mil. Now, after working that out, we get minus 1.53, well, times 10 to the 1, so that would be 15.3. Let's just correct that. 15.3 mil. Now we're going to want to convert this into litre atmospheres, so multiply by 0.001 litres divided by 1 mil, and that gives us minus 0.015 litre atm. We need to convert our answer into joules, and to do that we're going to write that W equals minus 0.015 litre atm, and we need to multiply that by a conversion factor which you can find in your textbook. However, 101.3 joules is equal to 1 litre atm. So let's multiply that out and we're going to get negative 1.52 joules. So in part C, our system is expanding against an external pressure of 3.7 atm. So let's put these numbers into the equation. Work is equal to minus P delta V, and that's minus 3.7 atm multiplied by delta V, which is 21.5 minus 11.3 mil. And that's minus 37.7 millilitres per ATM, and we have to convert the millilitres into litres. Minus 37.7 milliliter ATM times 0.001 litres per 1 mil, and that should give us minus 3.77 times 10 to the minus 2 litre ATM. The last step we need to do is to convert this into joules, so let's just write convert to joules, and we have W equals minus 3.77 times 10 to the minus 2 litre ATM multiplied by our conversion factor, which is 101.3 joules per litre ATM, which comes out to be minus 3.82 joules.